Hey guys, so a while back I did a video about the easiest solar generator, and I think I've topped that. I think this video might be the actual easiest DIY solar generator. So let's take a look. Check this out. This is a battery box from Licitti. Well, it's not just a battery box. It actually has in the lid a 1,000-watt inverter built in. So there's a power receptacle here. There's fan inputs and outputs. There is a 12-volt cigarette lighter connector. We've got USB and some more USB. Also, it has a 10 amp MPPT charger, solar charger built in. So on this side you've got a large Anderson plug, which will do up to 175 amps, provided that the battery BMS that you have installed in this unit will handle that. Then it has multiple 50 amp Anderson connectors. And then this top black one is the 10 amp solar input, the MPPT. Isn't this great? And so all we got to do is just add our own battery. So today what we're going to do is we're going to put this Timesusb battery into this battery box, and we're going to test it out and see how it performs. Is it any good? So let's take a look at this lid. So there it is, guys. There's the 1,000-watt inverter, and underneath the wiring here is the MPPT charge controller, and then it has various other components in here. This is the USBs and the cigarette lighter plug. There's some kind of large relay device here. I'm not sure what that is. If maybe it's a breaker or something. Then there's the on-offs, the main on-off switch. A little control board with the display, and then all of the Anderson connectors. And then the two main. It comes with the two main leads that are going to go to your battery. And then that's the inside of the battery box. It has a strap to hold the battery down. And then, yeah, these are handy. So it comes with these protective little boots for your battery terminals. Oh, and these are the bolts. The bolts to bolt the lid on. Like that. All right, well, I'm gonna put this battery in. How hard can it be, right? It's not gonna be hard at all. All right, so the battery is in. It was simple. And then let's put these little boots on the battery cables. There we go. Let's make sure that the main switch is in the off position. That way we don't get a spark while we're hooking this up to the inverter. Let's see. All right, it's connected to the battery. Now let's see if we can get this. I feel like that needs to go down on the side, like so. Oh yeah, oh yeah. Bam. Check it out, guys. Let's bolt it down. Even comes with a little Allen key. Wow. That was ridiculously easy. You'd be kidding me. All right, well, let's fire this guy up. Battery main switch. Bam. So we got multifunction display, battery display, DC voltage, AC wattage, mode 1, mode 2. Looks like mode 1, one touch mode button, manual flip display. Mode 2, button 5 seconds, every 3 seconds automatic display. Okay, I think that means it'll cycle through these different settings. All right, so I think we need to turn this on. Okay, there we go. So we're at AC voltage of 110. Battery seems to be completely full. Okay, so that's the cycle through. So 0 watts from the AC. DC voltage is 13.3. All right, there we go. We switched to mode 2. So if you hold this button down for long enough, it switches to mode 2, and it automatically cycles through these values. All right, so let's go back to mode 1. Doesn't seem to be going back to mode 1. Oh, okay, you just press it one time and it goes back to mode 1. Silly me. Okay, well, let's put it on AC watts and let's plug something into it and see what it does. So I've got a heat gun. Let's try that first. And this is should be 525 watts. Yeah. Can we see this? It says 500. I can't see it very well because they're light. There we go. It says 504 watts. Okay. No problem there. Let's try something else. Let's try this little heater. So, okay, we're pulling 720 watts. And now I hear the fan come on this unit. So I think there's 2 fans. There's one there and one on the back. This one seems to be blowing out. And I think this one's sucking in. So it seems to be running 700 watts perfectly fine. This thing can go up to 1500. I don't want to push this little inverter in here that hard. Let's try the next setting up. All right. So it looks like we're pulling 1064 or 1060 watts. So that's supposed to be 60 watts over what this inverter should handle. So don't really want to keep pushing it that long, but it seems to be handling it just fine. Battery sagged down to 12.1 volts. AC volts 109. So I guess this on-off button right here controls the inverter as well. Let's see if it turns it off. Yes. Everything turns off. And then you also have this main switch here that completely turns everything off. Cool. Let's plug some more stuff into it. It's actually doing 1130 watts. Well, we're overdoing it, but it seems to be taking it like a champ. And we need to check the other functions. Really, one of the things also I want to do is I want to open it back up, and I want to see what the idle current is. Okay, so it looks like it's actually idling at 0.35 amps. So that would be, what is our voltage here? 13.1. Okay, yeah, nice. It only takes 4.5 watts of idle power. That's not bad at all. All right, let's put it back together and then we'll test some more stuff. Drop it. Good boy. Down. Good boy. Go get it. All right, guys. So let's explore the USB ports here. So we got these standard looking USB ports, right? Let's turn this guy back on. We don't this just turns on the inverter, so we don't necessarily need that running to play with these ports over here. So let's just plug in a standard cable. Let's plug in my phone. Okay, it's just kind of a standard charge, I guess. So those are working. Let's try these other fancy USB ports. Let's try the USB-C right here. Oh, and there's a button here. This actually turns this port completely off. This one doesn't have a button, but this one does. Let's try that one. And I think this is a fancy fast charging one. Let's see here. Yeah, there we go. Turbo power. My phone says it's turbo power. Let's plug that into my laptop here. And it's got a very low battery. All right. Let's see what it says here. It says battery is not charging. Huh. It says 6%. I guess maybe I'm just going to leave it and let it see if it goes to 7. That way we know it's actually really charging. That's weird. Oh, it did go to 7, so it's actually charging. I don't know what. See, it's at 7% now. Okay, guys, let's see if we can cook some ramen. Why not, right? Let's see here. Let's do power level. Okay, we're overloading this thing. Okay, we're doing 1300 watts. And we need to go lower. Alright, so now we're below the 1000 watts. And we can already see a little bit of steam coming up. If we go a little bit higher, actually, so I mean, we're almost doing 1200 watts. It's only supposed to be 1000 watt. I think it's only 1000 watt. I don't remember where I saw that now. But interestingly, let's see, we can go over 1200 watts, almost 13, and then over 13 is when it starts alarming. Well, we're getting close to boiling over here, it looks like. I mean, I see bubbles forming on the pan. And when we do get to boil, I'll just turn this down a little bit more. I don't feel any heat. I mean, like, I feel a nice, good airflow coming out of this unit. Nothing's hot or anything. Now, of course, it's cold outside. That would definitely probably change if it's 100, 100 degrees outside. So running at this 1200 watts probably would be okay in the cold. But unlikely to be okay in the heat. I think we're real close to getting a boil there. So I'm gonna go ahead and throw that in. And I'm gonna turn it down to 3. Well, 3 right there. Which puts us at around 969 watts. That way we're not pushing that thing too hard. Alright, yeah, I think I think it's cooked these noodles. I've got it back up on the higher 1175 watts again. Seems to be working fine. I mean, you definitely can take this camping, and with an induction cooktop you could cook some food. Of course, if you're camping, you probably want to make yourself a fire and cook some food, but whatever, this will work too. I guess really the only thing this thing is really missing is a shunt, so you can actually see how much power is left in the battery, and that would be handy too for when you're solar charging. You'd be able to see power going, how much power is going into the battery, how much power is coming in from solar and charging the battery up. But one solution, actually, probably a better solution, would be instead of getting a cheap lithium iron phosphate battery, you could get a smart battery that has a Bluetooth BMS. Then you'd be able to log in and see the power going in and out and the state of charge of your battery. So that would actually be the solution, really. Alright, well, since that's cooked, I'm going to turn that off so we're not wasting any more power. Alright guys, so now we're going to try the solar charge controller. I had to build a cable because it didn't come with one, but I just built an MC4 to this Anderson plug. Let's hook this up to a panel. We can do a max of 45 volt input, so it's going to have to be kind of a smaller panel. So let's give it a shot. All right, so this is like supposedly a 130 watt panel, but I don't think it really is. I don't think it's actually going to show us anything on the display. No, not really. So I'm going to have to get my clamp meter and hook it up to see if it's actually charging. Okay. Let's see. Yeah. Huh. It's not doing anything. Interesting. Wonder why. Alright guys, so I figured out what the problem was. I don't know if this was intentional on their behalf, but the polarity was different on this one than the rest of them. So the rest of them are like negative here, positive here, negative here, positive here. And on the solar input one, it was reversed. So it's positive here, negative here. I don't know if that was just a mistake or what. But anyways, it should be charging now. And there we go. Well, we did have 6 amps. If I can get the cat out of the way. There we go. Now we're charging with 6.11 amps. Very nice. Alright. Well, I'm going to let this thing just keep on charging while we got some sun. Looks like it's going to probably move out. You know, move off after a little while here. So we'll let it charge up while there's some left, and I'll come back. Alright guys, well, we're kind of running out of sun today, and this guy's definitely not going to be fully charged. Let's see what voltage we're at. We're at 13.4, so it went up a little bit, but you know, we've got to get to it, you know, to 14.2 or something at least to fully charge this thing. But anyways, I think that's going to be it for this guy. I did do a measurement on the charge controller, and we saw it was pulling what was it, like 6.7 amps from the panel. And then I did check, put some probes in here and check the voltage, and I think it was like 15 something, but I did the math, and we were pulling 106.3 watts, which is really good. That probably 10 amp controller probably maxes out at maybe 1400 watt. I'm sorry, 130, maybe 140 watts. But if that's not enough solar for you, you could actually, you know, plug in an external charge controller into one of these extra Anderson connectors easily. So overall, I like this box. It works really good. I don't know the price point on this. This company just sent it out. They're supposed to send me some links to where you guys can purchase it, but all I've got right now is a link to their website, the product page. So I'll definitely put that in, and I'm going to email the company and ask them for some links. And I've also talked to them about maybe having an Amazon store so people can order it here in the US, because these guys are in overseas. But anyways, that's going to be it for this video. Hope you enjoyed it. Please like, subscribe. That really helps the channel out a whole lot. And I'll catch you on the next one.